Good afternoon, young people. Today we're going to be talking a little bit more about bonding, in particular, this idea of naming acids and writing their formulas, because we've got a series of compounds that is truly covalent because they're all nonmetals, but they behave ionically. So we've got not exactly covalent, not exactly ionic bonding. So that's what we're going to be talking about. All right. So acid nomenclature, pretty simple here. Acid nomenclature, acids are compounds that form H plus in water. Basically, in water, that H plus will attach to a water molecule, and it will actually create something also known as a hydronium ion, or something called H3O+. It's also known as hydronium. However, we really look as inorganic chemists at only the H plus idea. We will be bringing that up a little bit later in second year, so not too much that you have to worry about there in terms of what's happening. So formulas usually begin with H. So anything that begins with an H except for, let's go back, except for H2O or H2O2 are typically considered acids. In order to be an acid, instead of a gas, binary acids must be aqueous. So in order to be an acid, so we have HCl gas. That's not considered an acid. That's considered hydrogen chloride gas. But the moment it becomes HCl aqueous, we've bubbled that gas through a liquid and made this aqueous solution. This is the acid. Okay? Ternary acids are all aqueous, so any time we see a ternary acid, it will also have an aqueous, it will be in solution. Examples, HCl, hydrochloric acid. Notice the aqueous right here, and not gas. Nitric acid, HNO3. Sulfuric acid, H2SO4. So acid nomenclature is pretty simple. There are two things. If there's no oxygen, in other words, it is binary. If it's a binary acid, and it says no oxygen here, that makes things a little bit clearer, but most of the time we're talking about binary acids except for one example that I know of. The anion ends in "ide," and so what we do is we call it hydro, and then we use the stem of the anion, or the stem of the ending part, ic acid. So let me give you one that is pretty common. HCl. Okay, HCl, because it's binary, there's no oxygen in it, is called hydrochloric acid. Now another one that follows that rule is this one, HCN. HCN, that's hydrogen cyanide. There's no oxygen there. Because there's no oxygen there, we get hydrocyanic acid. Okay? It's not officially binary, okay? But it is one without oxygen. Okay, so if it has oxygen in it, it's going to be a polyatomic ion. It's a ternary compound for the most part. We're going to have ate and ite endings from the anion. And so what we do is we change the ate ending from the anion to ic acid, and we change an ite ending to us acid. Notice no hydro, there's no prefix. Easiest way to remember which goes with which: in the cafeteria you ate something icky. So ate ick. Okay? All right, so acids start with H. They start with H, and I'm going to get rid of my wonderful, beautiful face up here so that you don't have to see me anymore. Nope, wrong one. Sorry. Okay, so acids start with H. So we look, are there two elements or three elements? Okay, if there are two elements, then we have hydro prefix ending. Okay, I also want to write to the side here. Two elements or no oxygen. Okay, as in HCN that we looked at earlier, okay? So it would be hydro, some stem, ic ending, okay? Then if we have 3 or more elements, we have no hydro, and the 8 becomes an ic, and ite becomes us. So really simple to remember. So if we look at this acid nomenclature, I have HBr. Well, there's no oxygen, and it's binary. So that means we're going to begin with hydro, and then we're going to use the stem for Br. The stem for Br is brome. So hydrobromic acid. Okay? Now, this one has 3 and it has oxygen. So it's an oxyacid. So we know it's an acid because it's got H2 in the front. So CO3 we have to look up on our polyatomic ion sheet. So on the back of your periodic table you'll look up and you'll see that it's called carbonate, 8. So that means because it's ternary we get no hydro, but we change carbonate to carbonic. So carbonic acid. And this is the acid that we find in soft drinks. Sodas have carbonic acid. That's what gives them their bite. That's also why they taste flat when there is no more gas left in there. Okay, right here. So we see H2SO3. So we look up what SO3 is. SO3 is sulfite. Because it's ternary, it's not a binary acid, and it's containing oxygen, we get no hydro. But sulfite is an ite ending, so ite endings end in us. So we call this sulfurous acid. Okay, pretty simple when you think about it. So no oxygen ends in ide, hydrobromic. Has oxygen ends in ate, carbonic. Has oxygen ends in ite, sulfurous. Okay, hydrofluoric acid. What are we going to do here? Well, it's got a hydro. There are 2 elements. There's no oxygen. H and F make HF. And notice we use the ions. We use the plus minuses. Remember in the beginning we said they're covalently bonded, but they behave ionically. Here's their ionic nature. We're using hydrogen as the cation, and then the anion is the other part of it. So we have HF. So the next one is sulfuric acid. Sulfuric acid is made of 3 elements, and it ends in an ic, which means the stem ended in 8. So we have H plus and SO4 2 minus. So when we start evening that out, we get H2SO4. Nitrous, again, 3 elements because it ends in OUS, but remember the OUS translates. That means it was nitrite. So it's not NO3, it's NO2, 1 minus, 1 plus, we have HNO2. Pretty simple when it comes down to it. Okay, name them. What do you got? So I'm going to give you a moment. Go ahead and name those. All right, so what you would name this, it's binary and it has no oxygen. So this would be called hydroiodic acid. How about this one? Yeah, it's binary as well, so it'd be called hydrochloric acid. H2SO3. Yeah, sulfurous acid. Why? Because the SO3 is sulfite. Okay, HNO3. NO3 is called nitrate, so it would be nitric acid. Nitric acid is some pretty bad stuff because it doesn't just react with its H. The NO3 is also an oxidizing agent, and so the NO3 causes reaction as well as the H. And then finally we have periodate, so this would be called periodic acid. So write the formulas. Hydrobromic acid, hydro meaning that it doesn't have any oxygen, and so it's binary. So this would be HBr. Nitrous acid. Us meaning it used to end in ite, so that would be the nitrite. So we'd have H plus and NO2 1 minus, and that means my formula would be HNO2. Carbonic acid, we've seen that, H plus and CO3 2 minus, so that would be H2CO3. Phosphoric acid, the ick tells me that it used to end in ate, so that was phosphate. Phosphate is PO4 3 minus. Where do I find that? My polyatomic ion sheet. I have it on my periodic table. Every acid has H plus, so if I put those together, I get H3PO4. Okay, hydrotelluric acid. Because it's in hydro, we know that there's no oxygen there. And so that tells us also that it's binary. So I'm going to have hydrogen and tellurium. And so H plus is mixed with tellurium, which is a 2 minus. So I get H2Te. Okay, we are finished with this set of notes. So now it's time for you to study and finish the worksheet naming acids. Thank you very much.